Hey guys, so in this video I'm going to quickly go over a numerical example of a Cournot duopoly. I'm going to keep this quite brief and to the point, um, and hopefully by the end of the video you guys have a better understanding of what a duopoly is, a Cournot duopoly is, after I go through this example. So duopoly basically means that we have two firms. There's two firms competing in this market. That's what we mean by a duopoly. Cournot, basically, there's many different types of duopoly models, but in this case we're looking at the Cournot one. And this basically means that these two firms, they choose output, or Qi, for each individual firm, where I is equal to 1 and 2, because we have two firms. They each choose output simultaneously. So it's not sequential, it's not one firm goes and then the second firm goes after. In the Cournot situation, they both move simultaneously. So they're both going to choose their output simultaneously. And so because there's two firms, with each firm producing output Qi, the aggregate outputs of the entire market we're going to denote as big Q, which is just going to equal the quantity of the first firm plus the quantity of the second firm, because we have two firms in this duopoly market. So that's going to be our aggregate output. So in this example, let's assume that the market demand function is the following. So the quantity in the market, which is a function of the price, let's say is equal to 1,500 minus 3 times the price. So as normal, it's an inverse demand function for the industry. Negative relationship between price and quantity. As price goes up, quantity goes down. As quantity goes up, price goes down, etc. Inverse relationship. And let's say that there's two firms in the industry, because as we just said, we're looking at a duopoly, and that let's say that these two firms face an identical cost function, which is equal to the following: 10 plus 20 times the quantity that each firm produces. So here's our market demand function faced by all firms in the industry, which is going to be two firms. And here is the cost function that these two firms have, and it's going to be identical between those two firms. That's an important point to remember. So as I just said, here's the demand function faced by the industry. The first thing I'm going to do is rearrange this demand function and solve it for P. So we're just going to rearrange this here for P, which is going to lead to by 3. Now, keep in mind that what I quickly mentioned at the beginning is that the quantity, so the market quantity Q, is equal to the quantity of firm 1 plus the quantity produced by firm 2. So what we're going to do is plug this value for Q into this demand function that we've rearranged for P. So that's going to lead to it looking like this. All divided by 3. Now, with this market demand function that we've solved for price, we're going to now go on to the profit function that each individual firm is going to be faced, because each firm chooses quantity simultaneously. But what they want to do is they want to choose the quantity that maximizes the profits given the quantity produced by the other firm. So using that function that we have for price, which I'm just going to write down one more time, we can now kind of get closer to writing out the profit function and using this in the profit function. So what is our profit function going to look like? So quite intuitively, we can denote the profits using this symbol, but profits are just going to be the price, the market price, which is this function that we just derived, multiplied by the quantity that each firm produces, minus the cost. quite a simple normal profit function, price times quantity minus cost, makes sense. So it's important to remember how to interpret this profit and what our firms are doing, what our two firms are doing when they're maximizing profits. What they're doing, as remember at the beginning I mentioned that they choose quantity. That's the key point. In a Cournot duopoly, the two firms choose quantity. So they're going to choose a quantity or an output level that maximizes this profit function given the output of the other firm, because there is two firms. So that's what their goal is to do, is to maximize this. It's to choose a level of quantity that maximizes this profit function. So we've got our market price and we've got our profit function. Now let's look at the profit for one of the two firms. Let's say firm 1. The profit function for firm 1, now that we can start plugging in this value for the market price and the cost, is going to look something like this. So we plug in the market price, which we have at the very top, which is 2 divided by 3. We multiply that by the quantity of firm 1, because we're looking at the profit of firm 1, and then we minus the cost. And the cost function, remember, which I mentioned at the beginning, is going to be 10 minus 20 Q1. So this is our profit function for the first firm, and the goal of that firm will be to choose a quantity that maximizes this profit function given the quantity of firm 2, which we have included here in the function. So what we're going to do now is maximize this function. So when we maximize a function, remember we just differentiate it with respect to the variable that we're trying to maximize, which in this case is quantity. So we're going to differentiate it, or take the first order conditions of this function with respect to Q1, set that equal to 0, and solve for Q. And that will give us the value for quantity that maximizes this profit function here. So just to correct myself on something that I just said, to avoid any confusion, is that we're going to maximize this function. And so to do that, we're going to take the first order conditions, we're going to differentiate it with respect to the variable that we're choosing, which in this case is quantity, because our two firms are choosing quantity in this model that we've so far been looking at. And so because they're choosing quantity, we're going to differentiate this function with respect to quantity in order to maximize profits, since we're then going to find the value for quantity that maximizes this function. So I just wanted to confirm that. So let's go ahead and start maximizing this function, which, as I've just kind of gone over many times, we're going to take the first order conditions of this with respect to Q1, set it equal to 0, and then solve for Q1, or quantity, to give us the value of quantity that maximizes profits, which we've displayed here. So one thing I'm going to do before I differentiate this is just quickly expand out the brackets, just to make it a little bit easier to kind of differentiate. So this is going to be 500 multiplied by Q1, to be Q1 squared, so this is what we are differentiating, which is the same as this. I've just kind of expanded it all out so it's a bit easier to differentiate. So now let's take the first order conditions with respect to Q1, because this is again the profit function for firm 1, which we're looking at. So this is all going to be with respect to Q1. As you can see, these are all Q1s here. So this is going to equal 2Q1 over 3 minus Q2 over 3 minus 20. So as mentioned, we're setting this equal to 0 because that's what we do when we're maximizing a function. So now that we've taken the first order conditions, let's kind of simplify this function that we're left with a little bit more. So this with minus 20 can become 480. We'll take the q1 all onto the other side so that we're just left with q1 on one side, q2 on the other. So looking at this, we can multiply through by 3. So let's just write it out over here. So we can multiply this through by 3 to get rid of the denominator. So that's going to be 1,440 minus q2 is going to equal 2q1. So now it's fairly straightforward to get to q. All we have to do now is get rid of the 2, so we're going to divide this whole equation by 2, and then we have our value for q1 that is going to maximize the profit function that we initially differentiated. So that's just going to equal q1 now. It's going to equal 720, so this divided by 2, minus q2 over 2. So this is our value for quantity for firm 1 that is going to maximize the profit function that we were looking at on the previous slide. This is that value. So because each firm chooses output, or Q, simultaneously, and they're both faced with the same profit function, the outputs that maximize profits for both firms is going to be identical. Not identical as in this is going to be the exact same for Q2, because that would make no sense, because we want to have the value for Q2 that's going to maximize profits, not Q1. But it's going to be symmetrical in the sense that our value for Q2 that maximizes profits for Q2 is going to look like this. So Q2 is going to be, as I just said, symmetrical to what we have for Q1. So this should be, get rid of that, that should be Q1. So as you can see, they are symmetrical to each other. And this is because both firms are choosing output simultaneously. Both firms are sharing the market evenly between both of them. So, aggregate output, as we said, is this, Q2. They're both dividing the market evenly between both of them, and they're choosing that output simultaneously. The profit function that they're both going to be faced with is going to be symmetrical, and so the value for quantity that maximizes that profit function is also going to be symmetrical. They're going to mirror each other. So that's what our value for Q2 is going to be. If you want to kind of double check that, you can just do the exact same procedure that we just did for Q1, but instead do it for Q2, and you'll end up with the exact same kind of value for Q2 that we have here, that mirrors what we have for Q1. So we know that this is our function for quantity for firm 1, and this is our function for quantity for firm 2. Now that we have these two as a function of each other, we can solve this equation as like a simultaneous equation and get our values, our actual values for the quantity that each firm is going to produce in this market. So as you can see, this is like a simultaneous equation. So everything I do from here on out is just going to be basic kind of mathematics and algebra solving this for the values. So we can see here that we've got Q2 here and Q2 here. So I'm going to solve this function for Q2, and then that value I get for Q2, I'm going to plug it in here, and from that we'll then be able to solve for the value for Q1, which, because these are not identical, but mirrors of each other, these equations, that will be equal. Q1 and Q2 will be equal. So let's just start by solving this for Q2. So let's multiply this by 2 to get rid of the denominator, and that's going to be 1,440 minus Q2. Then get Q2 onto the other side, Q1 onto the other. And we can now that we have our value for Q2, we can plug this in here because we have Q2 equals this and we have another value for Q2 here. So let's plug in Q2 to that equation above, and we're going to get this. Then we can multiply this through by 2 again to get rid of the denominator. We're going to end up with 208 minus 4Q1 equals 1,440 minus Q1. So let's just combine the Q1s and take this 1,440 onto the other side, and we're going to be left with, it's going to be 3Q1 is going to equal 1,440. And then divide this by 3, and we're going to get Q1 equals 480. And this, because as we can see above, the two equations mirror each other, this value for Q1 is also going to be the same for Q2. You can do this same procedure, but instead of solving for Q2, you could solve it for Q1, and you'll end up with the exact same value. So this is our value for quantity that each firm is going to produce. Each firm is going to produce 480 units each. So the aggregate market output, which we know is this, is going to be 960. So that's going to be the total market output, which is just the sum of the two quantities that each firm is going to produce, which is 480. So now that we have the quantity for each firm, and this leads us to the aggregate quantity of the entire market, we can now get our value for profits. And the way that we're going to do this is first by getting the price, because remember, profits is price times quantity minus cost. So we need to get the price from somewhere. So now that we know what Q is, and if you recall our initial function for the market price that we derived at the beginning was this. Now that we have our value for Q, we can just plug this in to our price function for the market, and we'll get this, which is going to equal 500 minus 320, which is going to equal 180. So we know that the price in the market is 180 based on this value of quantity. So now that we have price, we have quantity that each firm produces, we have our cost function, which we mentioned at the very beginning, which I will bring back, we can now get profits. So this, let's say for firm 1, which because quantity is equal and they're both faced with the same market price, profits are going to be equal, because also remember the cost function was identical for the two firms, which I did also mention at the beginning. So because they're producing same quantity, they're faced with the same price and the same cost function, profits are going to be identical. So profits for firm 1, which is the same as profits for firm 2, is going to be price, which is 180, times the quantity that each firm produces, which is 480, minus the cost function. So let's remember our cost was equal to 10 plus 20Q. This was our cost, so when we minus this, and now that we plug in our value for Q, which is 480, we get minus 10 minus 20 multiplied by 480, which is going to give us profits of, if you've got a calculator handy, it's going to be 76,790. which is the profits each firm receives. So there we have a quite quick and brief example, numerical example, of what the outcome is going to be in a Cournot duopoly, with both firms choosing output to maximize profits, with both firms moving simultaneously, and with there being two firms in the market. So this is the kind of Nash equilibrium outcome. With this level of quantity for firm 1 and firm 2, they're both best responding to each other. But hopefully, with this kind of numerical example, that has helped a bit in your guys' understanding of a Cournot duopoly and what the outcome is going to be from that particular market structure. So thanks for watching.